Hello guys, thanks for watching my video today. Let's see another the Euler-Mascheroni constant. Okay, then is the double integral from 0 to 1 of x minus 1 upon 1 minus xy log of xy dx dy is the Euler-Mascheroni constant. Okay, so let's start proving this. So let our integral to be I, double integral from 0 to 1 x minus 1 upon 1 minus xy log of xy dx dy. Okay, now putting xy equal to u and treated x as constant. Okay, x to be a constant in this case. Okay, so x dy is du, right? Now coming back to integral, I is integral from 0 to 1. Here x is treated as constant. Okay, so it is not changed here. And integral from, now if for y, this is y, if you put y equal to 0, then u will be 0, right? If you put y equal to 1, so u will be x, right? And x minus 1 upon x is constant, right? X minus 1 upon 1 minus u is xy, okay? Log u, and dy is nothing but du by x, right? Du by x dx, okay? And then is integral from 0 to 1. Now taking out this x, okay? So x minus 1 by x, integral from 0 to x, du upon 1 minus u log u dx, okay? Now I is nothing but integral from 0 to 1. Now simplifying this is the same as 1 minus 1 over x, right? And integral from 0 to x, du upon 1 minus u log u and dx. And using IBP, now we are going to use the IBP and treated this one as a first function, okay? And this is second function, right? Okay, so using IBP, and if you use IBP here, in here, I mean this one is treated and this one is a first function, right? So first function into integration of second function, then is the integral of 1 minus 1 over x dx is nothing but integral of dx minus integral of 1 over x dx, right? So this is integral of dx is x minus integral of 1 over x is natural log of x, right? So here putting here, and minus integral from 0 to 1 of differentiation of first function, then is d by dx of this one u upon 1 minus u log u. And this is from fundamental theorem of integral calculus. We know that if you differentiate this one, then you get dx upon 1 minus x log x, right? So it is from fundamental theorem of integral calculus, okay? Okay, now putting that here, so it will be, now in the integration of this one will be x minus log x, okay, upon, and differentiation of this one will be 1 minus x log x, right? And dx, okay? Now if from fundamental theorem of integral calculus, if you put 1 here, so 1 time this is just integral from this is 1 is 1, so this is 0 to 1, right? Du upon 1 minus u log u. And if you put here log here, so log 1 is 0, so this root term will be 0. If you put 0 here, so this 0, so meaning this root term will be 0. And if you put 0 into this 2, so 0 to 0, okay? Integral of 0 to 0 of some function of this is just 0, okay? So right, so we are left with integral from 0 to 1 du upon 1 minus u log u minus this one integral from 0 to 1 x minus log x upon 1 minus x log x dx. Now from property of definite integral, So if you change this variable, it does not affect this integral. Okay, that's why I is integral from 0 to 1 dx upon 1 minus x log x minus integral from 0 to 1 x minus log x upon 1 minus x log x. Okay, dx, which is now combining these two, integral from 0 to 1, so this will be 1 minus x minus plus log x upon 1 minus x log x. The denominator are the same, right? Now separating this one and this. Okay, so that gives integral from 0 to 1 1 minus x upon 1 minus x log x dx plus integral from 0 to 1 log x upon 1 minus x log x. Now we can cancel this and this and this and this. What do we get? Integral from 0 to 1 dx upon log x plus integral from 0 to 1 dx upon 1 minus x. Now combining, I is integral from 0 to 1 over 1 minus x plus 1 over log x dx, which is this is already I have already done in the previous, that this integral approaches the Euler-Mascheroni constant, meaning our integral I then is this one is integral double integral from 0 to 1 x minus 1 upon 1 minus xy log of xy dx dy is the Euler-Mascheroni constant. Okay, so I hope this is clear. So thanks.